Thank you for joining, and I hope you are in the right session because there was some mess actually with this session. This is a last-minute session for filling a gap. So the committee asked me to present this session from Sunday evening, actually, and we had some discussion about which one to choose. So I hopefully you finally came to the right session. Remember, please, to silence the cell phones, to explore everything. So these are the first set of sessions in the morning. So it's the first time probably you see these slides, but coming into the day, you will see them many times. Please, very important. Everybody has told you about the session evaluation. And who am I? Just a few words about me. My name is Andrea. Martorana, Tusa is the family name. And I am from Italy. And I'm working in a company inside the Word group. We are doing stuff for building tools for buildings, fixing drills, hammers, whatever you need for professional building. And we are doing BI. I'm the manager for the BI team in one of the IT companies of the Word group. MVP for data platform. More or less 20 years of experience in SQL Server and speaker in many events worldwide. Of course, I'm based in Italy, so I'm speaking mainly Europe-wide, SQL Saturdays, a lot of events in Europe. And a couple of disclaimers, because it's a last-minute session, really. And we had a discussion onwards from Sunday. They asked me to prepare first a different session, but there was some sessions with the same topic already, so we discussed a bit, and we ended up presenting this session. And take into account that this session is very complex, because there's a lot of code, really. But please don't focus on code. Try to understand the concepts, how to build all the pipeline. Don't focus on code. If you want to code, you can ask me. I can give you all the demos. No problems. So don't be scared by the code. There's a lot of code, but don't be scared by the code. Just please to follow the flow. And really, if you get lost, please, if you think I'm talking too fast, please raise your hands and tell me slow down, or please tell me, Andrea, repeat. No issues, but try to follow me, please. And as an Italian speaker, I can have an exotic accent to you, so hopefully you can understand me. And I'm jet-lagged because it just arrived yesterday, so kind of jet lag. And you know, as an Italian, some body language is expected. And we say report, not report. I know the correct pronoun is report, but it's not natural for me. I'm saying report, so please understand it. OK, so we can start. After some advices, we can finally start. We are talking about R in SQL Server, how to use R in SQL Server, how to use machine learning algorithms in R within SQL Server, and how to perform some predictive maintenance, some failure and building predictive models using R into SQL Server, and how to deliver these models, how to display the data, outputting from R to Management Studio, reporting services, or Power BI. This session comes from my previous experience in a company, production company that manufactured hearing aids Okay, so we actually had a lot of data from production, and we had the issue of trying to predict the life cycle for an hearing aid from production, which component has the highest likelihood of failure, which component is going to break up more often, and all this stuff. So I'll show you some fake data, of course, but this experience came from a real life experience in the previous company where we tried to put up together some data from production, giving a lifespan for our products, and trying to investigate which component has the highest likelihood of failure of all this stuff. Okay, so let's start with some background introduction, R and SQL Server. So nowadays we have SQL Server machine learning services engine embedded into SQL Server database for delivering advanced analytics and data science. Today is called machine learning services. It started from SQL Server 2016 with the support from R. From the 2017 release, we also have the support for Python. So now it's called machine learning services. It started with the support from R, and we started building our models in SQL Server 2016, writing R code. If you want, you can replicate exactly the same stuff using Python. Depends on the language you are more comfortable with. All my samples are written in R, and R is the most common open source programming language for data analysis, for statistics, open source. And as I mentioned, we have R in SQL Server, native support for R in SQL Server, available from 2016. You have two options. When you are installing SQL Server, you have two options. R services, and this is what I'm using, directly integrated into the engine. When you are installing SQL Server, you have these two options. Or you can also install a standalone R server alongside with the database, but externally. But the straightforward way for using is installing R services straight into the SQL Server engine. And there also is a community edition of Microsoft R and the community client for Microsoft R. And, OK, I'll tell you later. So embedding R into SQL Server means that you basically can can improve performances. You can exploit the scalability and the performance of the database engine, because R actually is not well performing. So you can exploit the performances from SQL Server. The output is a tabular grid directly to SQL Server. And we have two packages suited for performing machine learning and resource governance on inside SQL Server. So these two packages, RivoScale R and RivoPMR R, are coming from the Microsoft version of R. It means that you need to install the Microsoft release for R. And this is exactly what I'm doing. I'll show you, but in my machine, in my laptop, I need to have R installed. So you need on the local machine to install R. And you have to install this Microsoft version of R. If you install the standard release of R, you do not have this RivoScale R package. OK? So my laptop actually have two versions of R. The general release of R for community, released from the R community, and the Microsoft release for R, that I'm using because all my demos and all my session is based on the RivoScale R package, actually. How to call R inside the SQL Server? There's a store procedure, a new store procedure, coming from 2016, SP execute external script. For embedding, either R or Python. We started with R, of course, from 2016. For embedding R or Python code into SQL Server. So we invoke this store procedure, pass, I'll show you. And we pass some parameters, and we got an output. So this is a very simple example on how to call R script in SQL Server using the SP execute external script. This is the standard store procedure. And then what you are doing is setting, declaring the language. So in this case, I'm calling R. I can either call Python nowadays. In this case, I'm calling R. And then I'm writing an R script. This is a very simple R script, of course. So you are passing all these R parameters. So you are invoking a store procedure, and then you are passing some parameters. Language script, this is the R script. And then you have to pass some input data to your store procedure. So some data are expected as an input into the store procedure. And this is the output. And this is the results set from R. This script is a kind of a hello world script, but actually it's working, and this is the output. So simply hello world, okay? But this script, this is how to build our script and how to pass the script to our our standard store procedure for executing external scripts into SQL Server. Just notice, please, that inside your script, all the data must be converted into what R is calling data frame. Basically, it's a table. So all the data into your R script must be converted into data frame in a tabular format, because what SQL Server is expecting as an output, it's a table. So inside the script, there must be somewhere the way to, no, sorry. No, come on. Call from Italy. No, come on. Sorry. OK, then data frame. Keep in mind, because you will see this kind of conversion in all my scripts. Moving on. So that was the general introduction on R into SQL Server and how to invoke our script from SQL Server for executing some data. And then how to perform predictive maintenance, because we have some built-in machine learning algorithms into our packages. Our goal, as I said, was to build some kind of failure prediction for the devices into my previous company. So we were looking for a way to using these algorithms for predicting outcomes. Of course, building some models and using functions. So if I build a predictive maintenance solution, I can predict the life cycle for a product in manufacturing industries. Just think about an aircraft component, a wind turbine, circuit breaker, and of course hearing aids. I discovered that an hearing aid is a very complex device. Actually, it's kind of a microcomputer. There's a chip inside. There's a lot of stuff inside this small device. So we had many components. So we had a high likelihood of failure for any of these components inside the production line. Okay, so it was really, really interesting diving into this solution. Of course, I cannot show you real production data, so we are using the old fellow AdventureWorks, the database, with some fake data for failure predictions. And we are predicting the failure for components of a bike. I have some data, fake data, with some failures from bike components. I mean, tires, brakes, whatever, builds up a bike. And we can apply our machine learning algorithms to these bikes and to this failure data, just to figure out which one is the weakest, which one has the short life cycle, and if there is any correlation between components and time and failures and all this stuff. What we tried to address, time to failure for a device, which component has the highest likelihood to fail, and if is an asset will fail in a different time windows, and blah, blah. So we started building up models. First thing you need to do is building a model, applying some machine learning algorithms. Building a model is quite straightforward, so you start from the data collection. I'm not spending much time on this slide because I want to show you the demo. So, of course, you start with data collection, preparation. Then you prepare a model. This is an important step. You prepare a model, and we will see 3 different models using 3 different algorithms, and train. This is the other point. So with some data, you have to train your model. It means that your model has to be trained, pass some data to your model to instruct the model. And then once you trained the model, you can run your machine learning algorithms. For instance, this one, I'll talk about it later on. And finally, pass some real data. Well, actually, the models, the data for training the model are real data. Maybe they are data from previous years. But if you want to perform a prediction, you can you pass data from, don't know, the last 2 years, for instance, or whatever. So some data must be, maybe all data must be used for training the model, and then some other data must be passed as an input for starting predictions. And you can afterwards perform scoring and prediction using this algorithm. It's called RxPredict, and display your output in yes. So, as I mentioned before, I'm only using this RivoScale R package from Microsoft R release, okay? This RivoScale R package has a lot of built-in functions. So if this is the web page for the RivoScale package, and on the left side you have all the functions you can invoke into the package. So you have to install the package, and then you have all these functions available. And we are using some of these models. So for from the RivoScale package, I'm using, first of all, of course, a predictive model always starts with a linear regression model, nothing special. So I'm starting building a linear regression model using this RxLean model, and this is the built-in model inside the RivoScale R package. And what I get is a linear regression model. Simple, quite straightforward regression model. But I'm also using a couple of other algorithms, random forest, parallel external memory algorithm for classification and regression. And this is the output of a random forest. And the third one is B3. I'm also using a B3 just to compare, OK? So we have 3 different algorithms. And as you can see, in 2 cases, they are giving the same output. The third one, this one, is giving a different output. Doesn't mean that one it's right, one it's wrong. They are approaching your data in a different way. And then it's up to us to understand which model is better, which model has the better accuracy, and which model we want to trust mainly. So this is another model. In this case, I'm building models and training my data. And what I'm doing finally is using this package. This is a function, sorry, RxPredict. So building models, training my data, and then invoking this function for performing predictions. OK? Start from previous data, from trained data, then building, calling this function for predicting failures over the time. So at the end, I will have, if I want to see what will happen into 6, 12, or whatever months, how many failures, which component, and all this stuff. Of course, I have to keep my example as simple as possible, but this is what I'm doing over the session. OK. That was the introduction. Hopefully not too boring. And then we can go and see all our demos and how to build the model. Any questions so far? Problems? Too fast? You are following me? OK. Nice. And yes, for the demo, let's switch over this virtual machine. OK, so first of all, this is something that I want to show to you. So as I mentioned, in this machine, I have 2 releases for R. OK? And what I'm using now here is the Microsoft R release, because it contains the RivoScale R package. So I'm telling this is R Studio, and I'm telling R Studio, please use the Microsoft release. And this is and likewise in Power BI, as I will show you later on. So I have 2 releases of R. The first one is the standard R coming from the community, open source. But for these models, for using these models and for using the package RivoScale R, I have to tell to my algorithms to use the Microsoft R release. OK? Clear? And you can simply switch here from the main environment on the R Studio. So this is R Studio, the environment where we build our R scripts and test it. My advice is to start writing the scripts in R, and then copy and paste. It's not copy and paste, but anyway, translate this script into SQL Server, because it's very, very, very tough having a clear output from SQL Server. Okay? SQL Server, because you are embedding the R script into a parameter. You are passing a variable to a store procedure. So it's very, very hard debugging what's going on the script. My advice is just test it on R, then change whatever you need to change, and embed the script into SQL Server. So this is what we're going to do. I'm going to call. So my first point is calling this package using R library, RiboScale R. So I'm calling the package I mentioned, because of course I need to use this package. And then I'm going to connect to SQL Server. So I am executing a SQL query on my SQL Server, because my data is on SQL Server. I'm a database guy, so my data is always on a database. But anyway, I'm calling SQL Server from R. And if you wonder how my data is, this is how my data looks like. So I have this, as I told you, I have this fake data. And I have, we are talking about bikes. And I have the category. So I have road bikes, touring bikes, mountain bikes. And then I have the date for the production, the date where the failure happened, if the product is still on warranty, and a failure description, which component failed. It was a brake, it was a gear, it was a frame, it was a tire, or whatever. So we have some data that we can build up and pass to our model. So this is what I'm doing, just calling data from SQL Server to R, importing data. And as you can see on the right, I have some objects here. And this is what I mentioned before, data frame. Actually, this is an out script, but you need to do it anytime you are invoking the store procedure from SQL Server, because the data must be converted into tabular model. Okay? And this is what I'm doing, convert the data into tabular model, and then show me the data. If you have a look here, this is my data from SQL Server to R. And these are 77 rows, basically, and 2 columns. This is the R way of of talking about the objects, but observations are rows and variables are columns, basically. So if I want to take a look on here, well, actually, I have this one. So if you see up here, no, down here, come on, yes. So I have these 2 variables. Columns are age, month, and total failure. So I'm passing the number, how old is my component, 20 months, 21 months, and how many failures I'm registering on this month. So on 20 months, I'm having 15 failures, and so on. And I want to build I want to investigate if there is any correlation between time and number of failures. This is, of course, the first question. The older is my component, the higher is the high likelihood of failure. The answer probably is yes, but we need some data to so if I'm building, I'm running this core. Core is the correlation coefficient in this R package. And this is the output. I have this one, a slightly positive correlation coefficient. Okay, it's positive, but it's slightly positive. It means that I have a correlation between the age of a component and the number of failures. It is not tight, but it is positive. The older the component, the higher the likelihood of failure based on this ratio. Fine. Then I want to translate these ideas into a model. So I'm building a linear regression model, calling this function, calling this function from my package, rxleanmode package. So I'm I'm creating a model, and the last instruction summary is giving me some informations about the model. So I have this linear regression model, total independent number of variables, and then I have some coefficients, so standard deviation, t-value, and some other statistical infos about my model. OK. Then what I want to do is I have a model. This is a simple linear regression model, but it's working. Then I want to pass some test data to my model, building a prediction. OK? So again, I'm fetching data from SQL Server. In this case, these are test data. So what I'm doing here, I'm passing some test data. So I'm telling to my model, this is the number of months, and I can change. This is a table. I can change it. So what I'm going to do is asking my model in 6 months, in 12 months, in 24, and so on, how many failures shall I have? And for doing it, I trained my model, and then I'm invoking a different. So I'm building, I'm passing some data from SQL Server to R, and then I'm invoking the prediction function. OK? rxpredict, passing the linear regression model, rxpredict. So please don't focus on all the code. Just keep in mind the most important that are the functions, basically. I'm exploiting some functions, some built-in functions from this package, RivoScale R package. So rxpredict, passing the model I built here. And in this case, I'm having an output, because this is my output. And R is telling me in what we gonna expect is that in 6 months, it's a linear regression, slightly linear regression, so the number of failures is rising over the time. What I expect is that in 6 months, you will have a certain number, and in 12 months, the number increases, and so on, OK? And this is a predictive model, because I'm calling the Rx package. So I could pass any value on the left column. Each month, I could pass 1 month, 2 months, 3 months. And actually, what I built in the both reporting and Power BI demos are that I'm passing the number of months as a parameter. So this is not a static value, but it's a parameter. OK. And the last step is plotting. So I want to plot my model. This is the linear regression model that I'm plotting using R. The second one, it's the predictive model. So this is the chart for the plot calling the predictive model. So this is the number of months, and these are the predicted values of failures over the time. Yes? No, I explicit invoked a linear regression function, this one. So here, I'm building a linear regression. So what I'm doing here is comparing these two values, total failure versus age month. And this is here. So this is how to compare these two values. And in the row below, I'm calling this function rxLin mode, telling build a linear regression model, because this is a linear regression model, from these two values. Okay? And this is training. I'm training the data. I'm building a model. It means that I'm doing some training for my data.
So
this is the training part.
But so the linear regression part is predetermined.
Yes.
Where are we with feeding the two values and find out the best regression that correlates raw data?
Yes. This is yes. Of course, I have to test the accuracy of the model and find out which model is more accurate and all this stuff. But this is out of scope, actually, from the session, because I have no time for doing everything. But yes, of course, you cannot simply rely on this model. And for instance, you will see that we are using 3 different models, as I mentioned before. And for 2 models, the output is the same. The third one is giving a different output. So which one to rely on? We have to build some accuracy test and to create some curves for telling us which model we want to follow. And in this other part, which one? Yes. Here, I'm invoking the predictive function, rxPredict, okay? Passing the model. So this is my model, my linear regression model, and I'm passing this model to rxPredict for having future prediction about my data. Okay. And that was the R part, okay? So I build up everything in R, even to calling this Microsoft specific package. But this is R. Now, the challenge is how to replicate these models and all this stuff into SQL Server. So let's start building exactly the same in SQL Server, calling my R sessions, my R models, building up an R model. And first point, now I am in a management studio. And first of all, please make sure that you have this setting on, because what you need is to enable the external scripts. So just run the sp-configure, because we need to have these external scripts enabled for calling both R or Python. OK, then I can start building up my model. So again, first, a simple regression model. This is exactly the same query I called previously from R, and I'm just pulling out some data. So for every month, for every age month, the total number of failures. OK, so now my goal is to replicate exactly what I did into the R script, invoking R into SQL Server. And this is what I'm going to do. So I'm calling this store procedure, sp execute external script. This is the parameter, R as a parameter, and then a script. I'm passing this data as an input data. No. OK, so this is my input data. It's a select. So I'm passing this data from my view into R. And then I'm making up some. So this is the way to pass the data from external input to R. And then I'm building a simple data frame in R, calling this, again, this correlation coefficient. So I'm calculating the correlation coefficient between, again, between age and number of failures. And if everything works, this is just running. So this is the output with the result set. Please show me this correlation coefficient. Still working from Management Studio. OK. And this is my output. And of course, this is exactly the same value as I had from my R script into RStudio. So first step for replicating the model using Management Studio. So I have this slightly positive correlation coefficient. Then I want to build, again, a linear regression model. For doing it, I could simply invoke this script. And this script, seriously, don't get scared about the script. I mean, some of this stuff I simply took from documentation, blog, forums. So you don't need to know exactly every clause, every instruction into the script. Just try to follow the approach. So again, calling this rxlean mode, this function from the RevoScale R package. And this is the output. So I'm building a model. But as I'm in SQL Server, and this is a model. Of course, this is a binary script giving me a model as an output. But what I want to do is, and I'm doing it for every script I'm using in SQL Server, I'm wrapping everything into store procedures. Because, of course, I can take advantage of SQL Server, and I can replicate and calling this store procedure every time I want. And as you can see, I could pass some parameters in some store procedure to make it, of course, dynamics. So the next step is having from this store procedure, I have a linear model, a linear regression model. I'm storing this linear model into a table. So I'm storing the linear model into a table. So this is my linear regression model. And then this is the execution time and the model output, a binary string. Of course, meaningless, but it's a binary string. So I have this model Why I'm doing it? Because all my models are stored into tables. It means that from an external output, like reporting services, I can call different models because they are stored in tables. So it's easier for me to invoke the models from an external reporting tool, such as reporting services. OK, then I'm doing exactly the same stuff I did before. So I have this sample table with some sample data for the months. So select from this sample table. And this is the way these are. Oh, sorry. No, that's fine because I have to calculate. So this is the number of months I want to pass for to my predictive model. But that's fine. So the next step is calling the predictive function. So I have this linear regression model. The model is stored in a table. And here I'm calling the predictive function for giving me the output. So this is exactly what I did before in R Studio, passing some data as an input to my R script. And then this data is OK. Is kind of unserialized, and then is converted into a data frame. And then from it, I'm calling the predictive function, telling give me, and this is the output, give me the prediction for the data I passed to the script. So for every month, for every yes month, tell me which one is the which number of failures I could have. And this is the output. And this is exactly the same output I had from my R script. So for every month. And this is the application of the linear regression model. So in 6 months, I will expect a number of failures in 12 months and blah, blah, blah. This data is fixed, but as I mentioned, I can pass this data as a parameter. And this is exactly what I'm going to do in both reporting services or Power BI. OK, so linear regression model. The model is stored into a table. And then I'm calling a predictive function for telling me what will happen in a time frame. 6 months, 12 months, 12 months, whatever you want. Of course, I would like to build a plot for my model because it's easier to understand, to read. But there's no direct way for outputting data as a plot because we are using a Management Studio. So there's no direct way, but there is a workaround. I can actually export my data, my plot, as an image. So what I'm doing here is generating a plot here from my, this is the linear regression. So I'm generating a plot for my linear regression for the correlation between age and the number of failures. And I'm telling to R, OK, please print it out, where into a local directory into my machine. OK? All this stuff, actually, I didn't know how to do it, but it's coming from some examples from SQL Server books online or from the community. So no need for knowing exactly all these instructions. But this is the output. What I want to have is a plot built from R into SQL Server Management Studio and saved into a local directory on my machine. Okay? If I run this script, okay, this is the output, a meaningless binary string, but if I'm going on this local directory, C temp rplot, this one, and if I go here, of course, my computer is set on Italian time, so actually this is the plot we just generated, but it's on a different time zone. So this is the output. From Management Studio, I told R, please write the generate a plot and save as an image into my local machine from Management Studio. Okay, so probably it's easier to figure out the data, and this is the linear regression model. And I can also use a very, very, very nice feature from R that is called phased wrap. Basically, with one line of code, you can split up all the components from your failures. We have some components that can concur on failures, as we have seen before. Brakes, gears, tires, forks, gear, chains, whatever. So if I want to split my linear regression model into every component, so I want to see how every component behaves, with one line of code in R, I can do it. And just think about, for instance, if you want to split your data into years, categories, whatever. In R, this is very, 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 very powerful, in my opinion. With one instruction in R, this phased wrap, you can split all your data into each component. In this case, this is the failure description. Could be here, could be customer category, could be product category, sales regions, whatever you want. Okay. So if I'm running this script again, I'm exporting this data into my local folder. Takes some time probably to run. Okay, again, mysterious var binary string, but if I'm going to go here, this is the output. So for every, I understand it's not that much readable, but come on. Gears, pedal, tire. No, sorry, that was, OK. Brakes, chains, whatever. So for every component, one single line of code, I have the behavior, so the linear regression for every component. OK? This is really, really powerful, in my opinion. Very, very nice. And there's no way, I found no other way to achieve it so easily than using R. OK. Move on. OK. That was about my, let's see, That was about my linear regression. Let's talk about it later. So, first model, simply linear regression. Then I want to build up some different models. As I mentioned in my introduction, I said that I want to use two other algorithms, okay? Random forest and B-tree. So I'm building a store procedure for using these two algorithms. So here I'm passing the data using the random forest algorithm. And this, I'm not digging into all this stuff, but basically what you can see here is that I'm passing some data as training data. 70% of my data from previous years is training data. And the other 30% is test data. And this is the seed, how to split up the percentage. So this, the 70% is for training, the 30% is for testing. But I understand it's complex. So don't be scared about this code. Just try to figure out the most important steps that are calling this random forest for building up a different model, and here calling the RxPredict for performing predictions based on this model. Okay? So I'm using a different model, different machine learning algorithm, of course with the same data, age and number of failures. And let's see, so everything is wrapped into a store procedure, and into this store procedure I'm passing two values. And let's move on. Yes, let's move on the other model, quite the same. In this case, into the store procedure, I'm calling, the code is almost the same. I'm just calling the B-trees algorithm and doing exactly the same stuff, performing kind of prediction using these different algorithm. Okay? Everything is wrapped into store procedures. Why? Because then I can insert all the data into a table. And the table I can use afterwards for calling different models for performing this kind of prediction. So I'm storing all my models into a data, into a table, and this is what I'm doing here. So I have these different kind of models, okay? These are my models, so I have some, and of course I can call these models many times, because maybe it could change the output from the model. So in this case, we have a few data, and of course they are static data because they are test data. So it's not changing, but depends on the data you're passing. The output for the model could be different. It means that you also have to estimate the accuracy for the model. So there is some other stuff needed before you can rely on your model. Anyway, just to give you the complete flow of a working solution, I have some models built in calling this. So I have my linear regression, I have the random forest, and I have the B3 model. And I want to perform some predictions using these different models. Again, what I'm doing is creating a store procedure. Everything is wrapped up into a store procedure. So this store procedure gets as parameters the model and the data. The query parameters means that I'm passing some data. Could be a simple select 12 as a number of months, but could also be data coming from a table. Okay, it's a query. It's a SQL Server query. So this is what I'm doing, wrapping everything into a store procedure, passing a model, and then here, this is what happens. So the data passed as an input into the R script is coming from my SQL Server query, and then the data is unserialized, building a model and performing a prediction, and outputting the data as a data frame into prediction. Let's have some examples. In this case, I'm calling my store procedure for the failure prediction, calling this model, random forest model. And I'm telling, OK, tell me what will happen on 23 months. So if I have a component older 23, how many number of failures I'm expecting in 23 months? Let's see. OK. So this is the prediction. In 23 months, you are expecting this number of failures. But if if you are using a different model with the same time frame, the total is different. Okay, it's perfectly fine because again, you are using different models. So in this case, I'm using the random forest. Below, I'm using the B3 algorithm. So for the same parameter, the output is different. Again, there's no a good or wrong model. They are different models based on different assumptions. It's up to us going to refine and trying to figure out which model is best fit for us. But there's no, it's science. So there's no out-of-the-box answer. OK? OK. And this is the linear regression model. And OK, let's see. So what happens if I'm calling this? So I'm calling the three models. In this case, the first one is my linear regression, the random forest, and the B3, passing some data. OK, so first two, linear regression and random forest, are giving exactly the same value. The third one is giving a different value. But that's perfectly fine. OK? Then let's talk about a few minutes about how to output this data. I could output this data into as I showed you before, into an image generated directly by Management Studio. And this is my image. And this is the number, the number of months versus the total failures. But I prefer wrapping everything into a table for showing this output using either reporting services or Power BI. So what I built is a reporting services report. It's not natural for me. Just move on full screen. OK. So this is quite interesting because I have mixed up a few different outputs. This is a standard reporting services tablix. Just calling the store procedure and having the correlation coefficient for every component. So age, number of failures, and for every component into a standard SQL Server, reporting services tablix, standard table from reporting services, I'm having this kind of output. But these two charts, these two plots, are coming directly from R. They are not native charts available in reporting services. This is the one you have seen before, using the phased wrap for splitting up all the linear regression into different components. And this is called, it's very hard for me, correlogram for comparing every component using the correlation coefficient for every component. These two charts are built using R. How to retrieve an R plot in reporting services? The trick is generate this plot into into Management Studio, store the plot into a table in Management Studio, and then call this plot from reporting services, telling reporting services that this is an image. So what I'm doing here is reading an image from reporting services database. Okay, I'm reading an image from Management Studio, from a table in Management Studio, and then I'm telling R this is an image. Reporting services, this is an image. Okay, so as I showed you, you can store the images, the plot as a var binary, basically, into a table in Management Studio. And then from reporting services, call the table, select from a table, from rplot table, telling reporting services this is an image. It's a var binary coming from Management Tools. Yes, 5 minutes, but this is actually an image. OK, second example, dynamic example. In this case, I'm calling the different models I generated in Management Studio that are stored into a table. So this is a dynamic report because I have this model, and this is the model generated from from Management Studio, from SQL Server, and this is the curve for the prediction, for the failure prediction. But if I'm calling a different model, this is the output. And this is exactly the same output I had from the previous model. And this one is a different one because this is the B3 model. So this is giving me a different, as you can see, the shape of my curve is different, even though I'm comparing the same time frame. And here, I can make it more dynamic, because again, there's a store procedure behind. So if I want to see what will happen in 8 months, for instance, just input the value as a parameter. And I'm calling, I don't remember which, OK. So I'm calling a simple tablix from the store procedure. So in 8 months, for every component, this is what I'm going to expect, the number of failure. And here I have simply a visual representation of the highest number of the higher component. And if I change, let's see, 23, no, not 23, 19 months. OK, so this report is totally parameterized. And the last one I would like to show you is, yes, 2 minutes left. So the last one I would like to show you is more or less same stuff with Power BI. What I'm doing here in Power BI is that I'm calling a store procedure, a SQL Server store procedure from Power BI. OK, so I have this store procedure in Power BI. This is the script from my data source, exec, the store procedure. And then this is a parameter. The number of months is a parameter. So I'm passing a value as a parameter into Power BI. And of course, my data is changing according to the parameter. So for 12 months, I have this output. So the number of failures for every component, which one is the weakest, let's say. And this one is very nice. And this is the radar chart, so you can compare all the components. But actually, if I go here, edit parameters, default parameters was 12 months. But if I change, let's say 5 months, I'm running. Behind the scenes in background, there's a store procedure, a SQL Server store procedure running. And of course, the values are changing, reflecting my the input parameter. Come on. OK. 5 months, and the values are changing according to the parameter I passed. Passing a store procedure to SQL Server from Power BI 11, and OK. Apply changes, and then it's running. And you can also call some other directly from Power BI. You know, there's the R support in Power BI. So you can also call some nice charts, box plot, correlation coefficient, some other nice stuff from directly from calling R into Power BI, either calling R or calling the SQL Server that is calling R, the store procedure that's with the R script encapsulated. OK, that's all. I know that was quite hard stuff. I saw somebody gave up, but so you were courageous. I appreciate that you are staying here till the end. These are my contacts. If you want to follow me up, you are welcome to write to me, to follow me, and we'll be happy to help you in giving any advice you need. Thank you very much.